Okay, I hope you've watched the procedure video on air content by pressure method, and I just wanted to kind of cover a few of the important details that are going to show up in both the written portions of the uh, certification test covering this method, as well as some of the questions that you're asked while performing the practical test for, for this method. So I just wanted to review again kind of that timeline that becomes important to us. Remember, you have 15 minutes to get your sample from the truck. You have to grab 2 portions um, within 15 minutes of each other to make your composite sample. And once you get to your test site, you remix those 2 portions with a shovel, so you've got a nice homogeneous representative sample. And your time begins within that first 5 minutes. Again, remember, you have to measure the temperature, you have to measure the slump, and you have to begin this air test. So all that happens pretty fast. And this week we're going over the air content by pressure method. Right, next week we'll do the other, well, one of the other methods, the other method that uses an actual device and not just a calculation. But this is by far the most common way of measuring air content, especially here in Montana. I just want to call out some of these bullet points here. We're using the Type B meter. ACI manual, I believe, even talks about a Type A, but they don't test you on that. They don't ask any questions on that. Everything we do and everything you're tested on is with this common Type B meter. And we talked a little bit about calibrating your equipment, right? Making sure your gauge is going to report results accurately. And the way you do that is down here in this bottom picture. You want to fill your pot with water all the way, because we know, unlike concrete that has intentional air, right, entrained air in that concrete, water has no air. So if we fill this pot with all water, put the lid on it, clamp it down, and then add additional water right through this petcock to fill up that little bit of void space on between the top of the lid, or top of the pot, and the bottom of the lid, we're going to completely eliminate all airspace within this pot. And then if we conduct this test, pressurize the chamber, right, release the main valve, your needle should reach 0% air. And if it does, your gauge is within calibration. And then you check it at a various couple other points. This little neck that you'll see in our equipment's case, the only purpose of that neck is to discharge water into this little tall, thin cylinder. And this cylinder represents 5% of the volume of this whole pot. So you can, while this is pressurized now, you can open up this petcock just enough and some of this water will discharge out, just like a faucet. And you fill up your 5% cylinder, close your petcock, or you want to seal everything, repressurize your chamber, and now when you release your air valve, you should read 5% air on your dial, because you know you've removed 5% of the volume of that pot worth of water. You then do the same thing. You discharge water out that neck, fill up this cylinder again. That way you should have a 10% air reading. And you can do this however many times you want, but that's how you're calibrating this equipment to make sure it's giving you good results on a job site. This test is not suitable for lightweight or porous aggregate because you're pressurizing this chamber and then forcing pressure down into that concrete sample. If you have really porous aggregate, that pressure is going to read the air that's inherent in the aggregate in addition to the air that you want to read in the actual concrete. So you're going to get false high air content readings if you use this test on like lava rock or rhyolite, like you'd find in Wyoming, on that kind, or like a seashells, or even like a calcium-based kind of aggregate that you might find in the southeast or near an ocean. So in Montana, we're lucky we have granite. We have very good strong rock. So this test is used exclusively up here. You're going to see these commonalities now among these tests. Like all these other tests, we fill the pot in 3 equal lifts, rodding each lift 25 times with your tamping rod, and they're going to ask you about the shape of that tamping rod, and it has a hemispherical or rounded tip. With each lift, you're going to smack the sides of that pot 10 to 15 times. Again, just like most of the other tests. The only test that you don't do that is the slump test. Thing to mention here that is not covered in the procedure video is if on your third and final lift while you're filling that pot you see that your concrete is going to fall below the top rim right down here and you're going to need to be adding more concrete, if you've started your roddings, right, you're going to go rod it 25 times, and if after 10 rods you notice that your concrete's falling deficient, you stop rodding, you add a little bit more concrete, and then you continue rodding where you left off. So you don't start over with 25, you resume with number 11 and then 12. So you still only want to rod that third lift 25 total times, even if you've had to add a little bit of concrete. Once you've added that third lift, remember you've got 2 choices to finish the top. You've got either a strike-off bar or a strike-off plate. This is what the strike-off bar looks like, and the strike-off plate is a 12 by 12 piece of plexiglass. If you're recording the unit weight of your pot before going into the air test, you have to use the plate. If you're just performing air test on this sample, you use the bar. One of the things that kind of stumps people is they want to close these petcocks at the wrong time during the test. And these 2 little valves here, these are your petcocks. And remember, those are used to add water after you've attached the lid to your pot, right? Because when you put the lid on top of that pot full of concrete, you've got a little bit of airspace in there. So you want to fill up that airspace so it doesn't give you a false high air content reading. And we do that by adding water with one of these little syringes here, or like the video showed, a little mustard bottle sample. You shoot water into one petcock, you can even tilt it on its side until you see water coming out this other petcock. And when you see water coming out in a nice clear solid stream, you know you've removed all the air. You still want to leave your petcocks open. You don't want to close these petcocks until the very, very last step. So that's when everybody wants to close those petcocks. But just try and keep in mind, leave them open. You're then going to pressurize that chamber. This is your pressure handle, and you're not pressurizing the whole pot right now, right? This little chamber, it's about the size of a can of Coke. It's sealed down here on the bottom, so you're only pressurizing the air inside that chamber right now. That's one of the reasons that you leave the petcocks open, is because if there's a leak, if there's a leak in your seal, you'll see concrete start flying out of these petcocks, and that means your equipment's no good. One of your gaskets is worn through or something. So really that's the reason you leave your petcocks open. But when you're pressurizing this chamber, right, you're going to pressurize it until your needle comes all the way to the right here and goes to your initial calibration line, generally around the 0 mark. When you pressurize air, you raise air's temperature. So after you're done pressurizing, you want to wait just a few seconds and let the air inside this chamber stabilize its temperature. And that'll be a question that's asked to you during the practical test. Whenever you're reading this needle, whether you're trying to set it to 0 for the initial line, or after you're done with the test and you're trying to read the results, right, you always want to tap that gauge. Tap the back of the gauge to make sure that needle's not sticking anywhere. So you're constantly kind of making sure that your gauge is giving you a nice neutral or unobstructed reading. when you read that final result, so it's kind of hard to see, but here's a detailed picture of a typical air gauge. You're going to read your results to the nearest 0.1% if your air content is down here between 0 and 8. And you can see the gradations here are marked. You got 10 little divisions between each individual digit. So you can report the test results with this tool to the nearest 1/10 of a percent. If you're over 8%, you'll see these gauges are only incremented to the nearest 1/2 of a percent. So over 8%, nearest 1/2 a percent. You're never going to see concrete in our trials, in our practice, that low. If anything, we make it a little too runny, a little too easy to work with, and our air contents are down here around 1.5%. Over 8%, that's really, really airy concrete. It's probably rare that you'd ever even see that in practice as well. And then the last question that's asked to you in the practical test is, what do you do if the aggregate has an aggregate correction factor? And that's kind of similar to lightweight aggregate. It's not true lightweight aggregate, but it's just if there is an inherent amount of porosity in the aggregate that's being used in that concrete, it might give you a slightly false high air content reading. So when the proctor asks you, what do you do if there's an aggregate correction factor, the adjustment is always you subtract that from the reading, right? Because an aggregate correction factor, an aggregate correction will always yield a false high reading. So you're always going to want to subtract out the correction factor. You won't have to do that for the mixes that we use, but you'll have to answer that question. Next week we will go over air content by volume method, which is the rollometer.